Well, hi and welcome to my shop. Thank you so much for joining me. Today is November 26th. So I just went ahead and replaced the last wax capacitor here in the tone control. And I want to thank a couple of you for sending me the idea that the schematic for a similar radio, a KM500, this is the KL500, that the KM500 actually fits better. And so I went through that schematic and compared it to what I have for the KL. And the only difference I could find is, in fact, the tone control capacitor is located in a different place in the KM. Otherwise, they appear to be identical radios. In fact, they appear to be the identical drawn schematic with just some changes made on the same schematic sheet. So I think what I'm going to do today, because to be honest with you, I'm very, very upset today, and I don't even want to talk about it. I should not talk about it. It's related to YouTube, and it's also related to tariffs. What can I say? Okay, let's take a look at the speaker now. Early on, I determined that the primary side was open, or at least the indications were that the primary side of this transformer is open circuited. On the secondary side, the wires that are coming out and going down here are the actual wires, that actual wire that's wound inside the transformer. And that's quite common in transformers. They just bring the wire right out and make a connection to some terminals or something like that. On this side of it, the actual wires which form the coil are not visible. Instead, they have these alternate wires which are going to travel down through the radio, because they did not want to extend this kind of wire, or the wire is so thin that it's just impractical to extend it out. So there's a really good chance that these two lead wires are connected just under the surface here to the real coil wires. And one thing I can try, a couple things I can try. One is, if I really want to be certain here, I would cut these two wires. Then I can test the transformer directly. There'll be no question about what's going on at that point. And then I can fiddle with the transformer a bit and see if I can bring it back. And what I'm thinking is the connections of the external wires to the internal wires just under here have failed. One of them has failed, and if I wiggle the wire, I can make it momentarily connect. And if that's the case, then that proves what the problem is, and then I can go after it. So the starting position is, to be certain about things, I should cut these wires. These are reasonably flexible here, so I can reconnect them. The color coding is clear. I won't make a mistake. So cutting them is actually a very good option. It's so good, in fact, I'm going to do it. I mean, the speaker doesn't work, so if I cut these, well, I was going to say, if I cut them, then there won't be any B plus going to the output tube. Have I checked recently for B plus on the output tube? I don't think I have. So before I make a stupid mistake, let me check that. I'm going to turn on the radio, and then we're going to look for B plus on the plate of the output tube. That's a 6K6. 6K6. Oh boy, it's hard for me to concentrate today. Oh my God. I shouldn't even be in here, really. Let's see. Think, man. Why are you looking at the 6K6? Oh my God. I'm just drawing a blank here. That's terrible. To find out the plate connection, so we can look for plate voltage. So the plate connection is on 3, pin 3. That's why I shouldn't be in here, because I am very upset. Me and every other Canadian and probably every Mexican is really upset we have an agreement with the United States. And the President of the United States has just tweeted out or truthed out, or whatever you want to call it, I'm going to abrogate the agreement that I organized when I was president last. I'm just going to abrogate it. What do you think is going to happen? Like, what do you think other people in the world are going to look at the United States and go, you can't make an agreement with that country. They're bullshitters. Wow, I'm really losing it here, aren't I? I got to stop for a minute. Oh my God, I'm losing it. I'm losing it, man. I'm losing my religion. Okay, let's give it. You know, I'm actually shaking. I'm actually shaking a bit. I'm so upset. Okay, number 3. I'm so upset because there's a good chance I'm going to quit my channel in a matter of a month or 2, and that's what's really burning my tail up. Okay. Just, you know, hey, what happened to Happy-Go-Lucky Jim? I'm the same as everybody. 1, 2, 3. Okay. I guess we need to turn this on to make it work, though. Okay. Give it a moment. First, we'll check for B+ on the filter capacitor, make sure things are working, and then we'll look for it down here, pin 3. Okay, it's got to be some voltage there already. There you see it on the meter. This is a 500 scale, so that's around 200. That's what this has been coming up to each time. I don't know if that's correct or not, but this is the plate. And that's pretty much a 0, isn't it? I mean, there's just nothing happening there. That's 1.5 volt, anything. So this is interesting. That's very interesting what just happened. I'm going to take the voltmeter lead off. Oops, I banged another lead there briefly. Great thing about vacuum tube voltmeters is it's pretty hard to damage them. Okay, so I'm going to put the lead back on the plate, and when I do, I think you're going to see the meter go up and then float back down. And that's what we want to talk about a little bit. Here we go. Oops, I fell off. Back on. Let me try it again. This time I'll be a little more careful. Just give it a moment. There we go. Well, what I was going to say, I think, is totally backwards. I was going to say the vacuum tube is full of an electron charge inside the tube that's not draining out because there's no positive connection. But you know what? That meter went ching like this. There is positive voltage in there. Well, you know what? If there's voltage on the screen and no voltage on the plate, that again should really settle it. I think the screen is pin 4. I'm going to make sure. And if this, I'm giving this radio every chance to show me wrong. HIJK 6K6. The screen, yes, is 4. So plate is 3, screen is 4. I got this on 500 now. Plate is 3, screen is 4. So you know, all indications are open circuit on turn this off. Open circuit on the output transformer. Now, in a very dramatic way, I'm going to cut the wires up here, and then we are going to test wires this way. See what kind of let's see, I want to do this where I can reconnect them fairly easily. This right here is just fine. The set is turned off. Okay, let's pull the plug out of it. There. This one's a little tougher. Right in here it'll be okay. Okay. So this one is a little stiffer than I thought. Wires with the cloth are difficult to strip with a stripper. There we go. Okay. And we take the ohm meter, stick it on there. I think on the schematic it might even say what the resistance should be, but it should certainly be something. If it's nothing, okay, man, what are you doing here? Now, I just remembered I forgot to do what I said I was going to do. It was stupid of me. So you can see open circuit, and that was I was going to wiggle these wires and see if I could reattach it. I can still do that. It's just I've already separated the. I'm just getting some clip leads here. Check these clip leads and make sure they're good. 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 Okay. So I'm going to clip the wire to the ohm meter. So you think if the connection inside here that I'm talking about has separated, the separation is not much of anything, really. It's really close. So the idea would be to mechanically manipulate it so that the contact is restored, and then we'll see it on the ohm meter briefly. Okay, first I'm going to short these to make sure we're working here. Short? Yep. Okay, yeah, all eyes on the meter. Get nothing whatsoever. Now look at the two wires. You know, one may be going deep into the back of the coil and the other may be on the front. Or they may have made both the connections right on the front, which is more typical. So I'm going to try moving one of these wires a little bit. Watch the meter. Try moving the other one here. And there's nothing happening. So, you know, what other reason would a coil of wire stop being a coil of wire? That's a good question. Well, let's see. My options here are to remove this from the radio at this point and work with it out on the bench. And I could easily do that. Let's do that. I'm going to do that. That sounds good. So what I need to do is desolder the voice coil leads. Patience, man. And I'm a little upset. My patience isn't there either. Come on, man. There we go. Come on. Am I heating the whole speaker? There. Okay, pull the yellow one out. Now, in terms of replacing this output transformer, there are some ideas floating around out there. I'm not sure what to make of them as alternatives. Maybe it's the case that almost anything will work as long as the turns ratio is close. But there we go. Okay, got that one off. Looks like green Roberts. Whoops. Careful. Careful, careful. And you know, could I buy a new one of these? Probably, but look, this radio's not mine, and it's not going anywhere. It's not worth the effort. That's what I want to say. It's not worth the effort. Not worth the expense. Somebody else could do that. Okay, let's take a look at this. Okay, I'm going to stop for a bit. Get ready for that. Okay, this is a one-way trip for this transformer, I'm afraid. Let's whoop, watch your hand there, Jim. You see I still have the voltmeter connected. And so keep an eye on it. Voltmeter, the ohm meter. Okay, one more layer. Another layer. Take a really close look at what we've got here, because the connections are here. One here and one here. Let's take a closer look. I have my other camera handy here. Let's get it right in there close. Fortunately, I'm going to have to probably fiddle with the focus on it. Yes, I will. So I'll let you look at the wild mouse action here. I'll let you look at the autofocus image while I take over manual. Oh, there goes the automatic focus. Well, I'm going to take over manual control of it. Wow, that's pretty good right there. So we can see the one on the left and the one on the right. Wow, they look pretty good to me. Just looking at them. How's our volt? Our ohm meter is still showing. Still showing what it's showing. What exactly are we seeing there? So it looks like, get my pointer, make sure I'm understanding this. The two wires are coming in at the bottom. They're traveling up under this tape, and then this twisted part here must be from this wire, from the wire coming out, and then it's making contact with something in this ball here. In fact, you can maybe even see the other wire right here. The side, when we look at the other side here, again, so we see the wire coming up and over. Oh, jeez. That's my voltmeter there. Ohmmeter, rather. Just turn it right off. I better not turn it off. Start poking at this at any moment. Now you can't see the camera, the voltmeter, but I can. So I'm gonna poke at these a little bit. I'm watching the voltmeter again, the ohm meter. I'm watching for any jump. Any jump. Somebody jump. Nobody jumping. guess we can put the ohm meter right on these two what look like solder balls here and see what we get. But I can't imagine it's going to be any different. But I think we got to give it a try. As you can obviously tell, I'm trying to step this through this very carefully. Anybody, anything? I didn't see not a thing happening there. It's just a slight, a little more than a slight touch. No doubt the voltmeter is periodically taking a reading from the prods. You got to have them on long enough for the reading to be taken. There's nothing happening here at all. Let's take off this next layer here and see what kind of trouble we can get into there. Oh, wait a minute. Wait a minute. What are those fine wires doing there? So this is, no doubt, this is the actual wire coming from the coil. What's happening is I'm looking at a computer screen while I try to do this, and what am I trying to do? I don't know. I'm just moving it around. So it's pretty clear that this end is the connection end. The other end is disappearing into the coil. Now if we look at the other one, you see the same sort of thing. The wire's kind of up here, kind of wildly loose. So can I test to the actual wire? I'm going to bend it enough it'll break. Now the interesting thing about copper is it's resistant to being broken by bending, because the copper work hardens, which means when you bend it, the area that has actually been distorted by the bending gets harder, and then it won't bend in that location again. So if you try to break a piece of copper, it doesn't go well. You'll find the bend point keeps traveling up and down the wire away from where you want it, because the wires become much harder from the bending. So I don't have my own meter connected here. Shoot. Okay, ohm meter connected. Nothing seen, no. Okay, what's the next step on this? The next step is try to read right on those wires. Now those wires are going to be coated with varnish. Another thing I could do is I could simply reheat these connections, and that wouldn't be a foolish idea either. Just reheat these connections with a soldering iron. You know, I mean, it's a long shot, but it's worth a try. I guess it's quite possible that if failures occur deep inside the transformer, that would be from something like maybe an original wire defect that may have existed. Soldering, excuse my reach. I'm watching the ohm meter while I do this. Nothing happening. Okay, we'll do the other side. There's just nothing happening. It's boiling here, so there must be some moisture in there. Wow, I really can't imagine that that this can be saved at this point. I mean, okay, I'll stop for a bit and ponder the situation, but it's not good. Well, you never know what you're going to find. I rummaged around, and lo and behold, didn't even know I had this. Wow, here we are. There's a transformer. Yeah, should I say one more? Well, first off, could you just substitute this for this? You probably could. You probably can. You probably could do it. There's 4 wires coming up here, but really there's 2 pairs, one pair driving the field coil and the other pair going into the primary of here. Looks like there's a hum coil connection here. The voice coil lead comes down. Yeah, just comes out of the coil here. But that doesn't matter because there's a voice coil. Now, on the other radio, was there a hum coil? I think there was. Does it matter? Gee, I don't know. Okay, how's this held on too? It's like, well, it's just been smashed on there. Just bent these metal tangs this way. So, those metal tangs. If I could bend them all the way out, they would become the screw holes. Probably not the same dimension, but even if I just get one screw to hold this in the radio. Do we know this is any good? How would we know that? How could we find that out really fast? So let's check and see if there's any magnetism in here. Yes, there is. There's a lot of magnetism left in here. That means the speaker will actually operate even without the field coil being energized. Although it might be quiet. So if we pop, I don't care about the speaker, we want to pop some voltage onto here, which you hear some clicking come out of the speaker transformer. Good. Which leads are which here? Oh my gosh, how can we tell? Wow. Color code. Just try different combinations until we hit one that actually produces an output. That's probably the easiest thing to do. So we need a little bit of voltage here. This battery could very well be dead. Let's just don't need much. Anybody home? Oh yeah. It's all there. 9.5. We literally do this? I think so. There we go. Hear that? Might be hard for you to hear it, but I can hear it. So probably if we hook up to the field coil or to the primary side of this, we're going to hear it. So we hear it in 2 positions. very consistent. Yeah, there's no way I'm going to be able to trace the color of the wires back here, I don't think. Well, the fact that we can hear it, in a couple places, I think it indicates this is good. What we would want to do is separate these wires, cut them, and then identify for sure what the primary is going in here. As for the secondaries, now one is right here. It's perfect. The other one is missing in action. Where is it? So, oh, here it is up here. It's hidden from view. Oh, so that's going into the hum coil and coming out of the hum coil and going here. So this guy would be the secondary wire, the wire we would want to hook up to the voice coil. It's all here. So getting this off, getting the wire separated, putting it temporarily at the radio and connecting it up. I'm just going over what I have to do here. You don't need to make this bolted down to the radio to find out. But what I want to do is I want to kind of jury rig it and see if this works. That's basically what it amounts to. I could do it with right here. Interestingly enough, if I ran the primary current from the output tube through this transformer, it would probably make sound out of this speaker, even without the field coil being energized. That's a pretty interesting idea. Not that I want to put this speaker in that radio, because the fat chance this would fit physically. It looks to be about the right size though. Okay, going to think about those things a little bit, and then we'll see what we do. Well, it's gotten rather late here, so I think I'm going to stop right at this point, and tomorrow I'll pick up on trying to deal with this transformer. Maybe in the meantime today I'll get it off the speaker so we have it separate and can work with it. So thanks a lot for watching to this point. Who knows what's going to happen here. See ya.